Okay, welcome back. So in this video, we're going to look at substitution and transposition. So transposition is kind of like what we've already been doing, except we're going to be given an equation with no numbers. So we're sort of doing the same sort of thing as solving equations, except we can't actually do any mathematical calculations. So we're just going to end up with rearrangements. It's essentially just rearranging equations. But first of all, we're going to look at substitution. So I sort of started talking about that in the previous video as a way of checking that our equation solving was correct. Except the only difference is we're going to be substituting in multiple numbers and then calculating. So just going to jump straight in. So this is the first one. We're given this equation. So capital C equals capital V multiplied by X plus F. Doesn't really matter what they stand for, but we're told find C when V equals 12, X equals 3, and F equals 25. So really, we just have to, we're substituting these values into this side of the equation, remembering that there's a little times in there, and then once we've got those numbers in, we're just doing these, we're calculating what that result is. So, first thing to do is write it out again, except substituting in the numbers. So we've got C equals V equals 12. Don't forget there's a little times in there. 3 plus 25. So if this number was negative, that would flip the sign of what's going on over there. So first thing, 3 times 12, because we do the multiply first, is 36. That's 25. So notice I'm only doing one thing at a time. It sort of shows your logical thinking steps as you work through a problem. Just whenever you're doing any of these algebra stuff, just do one thing at a time. And then if your final answer doesn't quite come to what it should, you can work your way backwards through your steps and maybe find that tiny little mistake you made. Also with marking stuff, by setting out the lines, each time you change one thing, write it out again, write it out again, change something else, write it out again. And then for teachers marking, if your final answer isn't entirely correct, we can still look back at what you were thinking. And if we can pick, oh, you accidentally turned that plus into a subtract, that's only a tiny mistake. But if everything else is correct, you'll get most of the marks. So the final step here, 36 plus 25, 5 plus 6 is 11, carry the 1, 2 plus 3 and 1 is 61. So in this equation, just get rid of that. If these are the values of these variables, then the thing on this side of the equals is 61. So really, substitution is putting numbers in for the variables in an equation and calculating what they all combine to. So that's the first example. A nice easy one. Okay, I'll get rid of that. So the next one is, now we've got an area. So if, I'm just sort of writing this out like it is in the book. If area equals pi r squared, so we're talking about the area of a circle. Find the area when, text is running out, let's change to blue. When pi equals 3.14 and r equals 4.5. I don't have a calculator to hand, so I'm going to have to pull out my phone. Right, so this little 2 above, I think we've already seen stuff with powers, so it essentially means it's this term underneath, just the r, multiplied by itself, multiplied by that. So I'm going to substitute in our values for pi and r. So area equals 3.14 times by 4.5. I'm just going to put brackets around that, squared. So really this is 3.14 times 4.5 times 4.5 again. That's what the little 2 means. So because we've got decimals, that's why I'm using a calculator. I can't do these ones in my head quite so easily. 3.14 times 4.5 times 4.5 equals 63.585. We'll leave it as that. Now, because it's an area and we don't know if this is centimeters or meters or kilometers, I'm just going to say units squared. So really that's length is just the units. When we're talking area, it's squares. So that was pretty easy. The next one, I think we're going to recognize, let's get rid of that. We're going to recognize this formula. I equals P RT PRT, simple interest. We've already looked at this. So notice we've got a capital R here and it's over 100. So really this is the same as the one we were using. So this little r is the full percentage divided by 100. So just convert it into a decimal. But we'll stick with what they're giving us for now. So find the interest when P stands for principal is 1,000, and we know that those are going to be dollars. Capital R is 8, so that's 8%, and T equals 2.5, so that'll be 2.5 years. So we're just going to substitute these in to this, and these are all multiplied together. So I equals 1,000 times 8 times 2.5, all divided by 100. So really this 8 divided by 100 is our decimal version of the percent. So let's just type that in. So I'm just going to do the top bit first. So I'm still going to leave this over 100. Just going to do the top bit. 1,000 times 8 times 2.5 equals 20,000. But then divided by 100. Really, we can just cancel those. Equals 200. And we know they're dollars because we've already looked at simple interest. So as far as substitution goes, we can be given all sorts of equations, and as long as we're told the right numbers to substitute in, we've sort of already done this. then we can work out what the thing on the other side of the equals equates to. Probably the best. I didn't want to say equals twice in the same sentence. Okay, so I think that's all the examples we need of substitution, because we've sort of already been doing it. Okay, so the next thing is transposition. And really all it is rearranging an equation, but without actually doing any maths. If we're given an equation with lots of letters in it, we can just rearrange those letters as long as we do the same thing on both sides. Okay, so there is a worked example in the book that we'll just go to. Here we go. 1.9. And okay, we'll just do these one at a time. So now we've got a y, curly y, not a y, plus 3x equals 0. And so for these first few examples, we want to make what, and this is the terminology we use. I'll just write it out. Make y the subject. That's just the terminology we use to mean move everything to one side of the equals and leave y on. So we want to end up with an equation that is y equals everything else. So this one's not too bad. In the same way that we were moving stuff, collecting terms, we just need to take this positive 3x or add 3x to the other side of the equals. So to do that, we're going to subtract 3x, but we've got to do it from both sides. So over here, we've got y, add something, take that same something away, so that cancels out. It's like y plus 0. So we get y on its own. And don't get confused, we've got starting at 0 and then we're subtracting 3x. So y equals negative 3x. That's really, so we've ended up with y on its own. We've made y the subject and everything else is over here. Okay, the next one. I might just leave that there. I think we'll fit it in. Let's just put a box around that. So the next one, 2y plus 5x take away 6 equals 0. So the same thing, it wants us to make y the subject. So we want this bit, just the y on its own, on one side of the equals and everything else on the other. So the first thing, we need to take the 5x away from both sides, and we also need to add 6. So I might do both of those steps at once. So I'm going to take away 5x, and because we're taking away 6, I'm going to add 6, and we've got to do this to both sides. So take away 5x plus 6, and because we got 0, we're just going to end up with negative 5x plus 6. Over here, that cancels with that cancels with that, and we've got 2y equals negative 5x plus 6. So I've just, essentially the signs have reversed when we moved it to the other side. But this is 2 lots of y, and we just want y on its own. So we need to divide both sides by 2 just to get y on its own. So over here, divide by 2. Now, this is everything, not just this term, but both terms. Divide by 2. I hope you're okay with that, having 2 terms at the top of the fraction. So over here, they cancel. So we've got y on its own, but we can simplify this a little bit. So let's just write it here. So we've got y equals. So we can split this too. So we're dividing both things. So in it, we could write this as, split that, divide that by 2, and divide that by 2. That's sort of the same. When we're adding fractions, if they've got the same denominator, we can combine the denominator and add the things on the top. So I've just sort of gone backwards there. So negative 5 divided by positive 2, we can write that as negative 2.5, and this is lots of x, plus 6 divided by 2 is 3. So that is probably the simplest way to write that. We could have left that as negative 5 over 2, but I think half of 5, that's a good enough solution. I hope that was okay. I hope doing two things up here didn't complicate things in your brain. Okay, so we've got one more of these, making y the subject. Yep, let's get rid of everything. Okay, so this one, 2x plus half y equals 9. So we've got things on both sides. The first two examples started with a 0 over here. So, and we still want to make y the subject. So if we look at what's happening to y, it's being multiplied by half, and it's having this thing in front of it added on. It doesn't matter that these are round the other way, because 2x plus half y is the same as half y plus 2x. When there's a plus between things, you can think of them as being, you can swap them around. Doesn't work with subtract. That's why plus is good. Plus is positive. Okay, so first thing I'm going to do is we want to move this positive 2x to this side of the equals. I'm going to subtract 2x, and I'm going to do the same thing on this side. Keeps our equals true. So here, plus 2x, take away 2x, that cancels out. So on this side, we're left with half of y equals 9, take away 2x. So we can't combine those because they're not like terms. This is a multiple of x's. This is a multiple of 1's. So we've got 9 1's, take away 2 x's. So the last thing to do, because we want y, not half of y, really, we need to multiply both sides by 2, because this is only half of what we want. So I'm just going to write it out again. Leave a bit of a space. And now I'm going to put brackets around both of these and multiply both sides by 2. Like that. It's probably the best way to think of it. So we've got half of y twice. 2 lots of a half is 1. Half a cake plus half a cake is 1 cake. So here they cancel and we get y on its own, which is what we're aiming for. And on this side, the 2 has to multiply by both things. So 2 times 9 is 18. 2 times 2x is 4x, but it's being subtracted. So we're taking away 4x. And that is our final version of what we started with, but we've made y the subject of the equation, getting it on its own. Okay, so that's transposition, where we've got some numbers we can actually combine. We've got a few more examples where we don't have any numbers, but it's the same process. Just what we can't do is things like multiply the 2 and the 9 and the 2 and the 2, stuff like that. But hopefully it'll make sense. So we're not making y the subject in these. So the first one, we've got that equation that we started with, c equals v x plus f, and it wants us to make x the subject. So I'm just going to write it like that. That's how they've got it in the book. So there's our x. That's the thing we want on its own. And remember, so we've got x is being multiplied by v. That's the first thing that's happening. And then f is being added on. So like when we were solving equations, we need to undo all those things to leave x on its own. So we can't really divide by v yet because we've got this thing stuck on the end. So the first thing I'm going to do is subtract f from both sides. Subtract f. So don't get these round the wrong way. So we've got c, take away f, equals, so that cancels out. We're adding something and then we're taking that same thing away. We don't know what it is, don't really care. But all we're left with is v multiplied by x. So now, because this is what we want on its own, we got v lots of x. So we want to get rid of the v over here, move it to that side. So it's going to divide. That was a number, we'd know what number to divide by, but because we don't, we're just going to divide by capital V. And we do the same on both sides. So over here, v, how many v's? There's 1. So this is like multiplying x by 1. So that cancels there. We've got x on its own, which is what we were aiming for. So I'm just going to write it out. I'm going to put this x on the left-hand side. Equals c, take away f, all divided by v. And that's our transposed version of what we started with, except we've made x the subject. Okay, I'll leave that one there. Let's get rid of that. So we've got the next one is s equals d over t. We want to make t the subject. So in case you're not sure what this equation is, speed equals distance over time. Now, the thing to be careful of is if we want t as the subject, so this isn't being multiplied, this is our equation. Please notice that t is on the bottom of this fraction. And what we don't want, we want t just as a number, not t at the bottom of a fraction. So what we're going to do here is, instead of trying to move the d away from the t, we want to bring the t to the top of the fraction. So what we're going to do is bring this t to the other side. We're going to cancel it out here. It's going to appear on this side, and then we'll leave it on this side and move the s back to that. You'll see. So let's just rewrite this out. S, leaving a bit of space. And what I'm going to do is, let's just put this in brackets. I'm going to multiply by t here and multiply by t there. So the effect that has is we've got t essentially being divided by t. T, how many t's? Over here, that t disappears. And over here, we've got s times t. So now we've got s t equals just that d on its own. But because we want, so now we've got t essentially at the top of the fraction, this is like over 1, we are now going to divide both sides by the s. So here, s, how many s's? We've just got 1, so that cancels. And we end up with t time equals distance divided by speed. So we started with this one, we rearranged it, we transposed it into this, making t the subject. Cool. Okay, so we've got one more example before we call this video to a halt. Yeah, let's get rid of the whole thing. So the thing to be cautious of here is we've got capital T's and lowercase t's. So just be aware that they're different. They're standing in for different numbers. So we've got capital W equals S away T, all divided by little t. So I'm going to write it as curly t because I don't want it to look like a plus. And we want to make capital T the subject. So that's not this, don't get confused, this, it's also a t, but it's not the capital T. So these two variables are different. Just checking. Okay, so we've got this whole thing being divided by little t. So what we're going to do is we want to end up with this on its own. So the first thing I'm going to do is get rid of this t at the bottom of the fraction because it's kind of, it's making a mess of stuff. So W, I'm just going to rewrite out the whole thing. And like we did before, I'm going to put brackets around both sides and multiply by little t. So on this side, we're multiplying by little t, we're dividing by little t, so they cancel out. That essentially equals 1. So it disappears on that side, and over here we've got big W multiplied by little t equals S take away t. Okay, so we want this on its own, but we don't want negative t. So we'll deal with that take away t thing last of all. So the next thing to do, we've got this positive s. So we're just going to take s from both sides. So over here, that cancels out. It's like adding nothing. So we've got WT take away S equals, and don't forget that this is like 0 take away T. So we've still got negative T. Now essentially, when we have no number in front, that means it's like one of them. So this is like negative 1 multiplied by T. So in order to make this go away, we can multiply or divide. Multiply would be easier. Let's just put it up here. I'm going to rewrite this whole thing. Equal negative t. So I'm going to put brackets around both of these. So we want to get rid of that negative, so I'm just going to multiply both sides by negative 1. Multiplying by 1 doesn't really change anything, but the negative will swap, it'll turn positive things negative and negative things positive. So over here, Negative times a negative gives us positive t. That's what we're aiming for. And over here, we've got negative capital W little t, and then a negative times a negative, positive s. So just to make it look a bit nicer, I'm going to write the t on the left-hand side equals all of this, and I'm going to write the s at the front, so then I don't have to put the plus, and we're taking away wt. So this negative is attached to that wt term, and because it's a plus, we can move things either side of the plus and it's still the same result, but we're sort of adding the negative version of this, which we can just write as subtract. I hope I didn't add in too many issues there at the end. Hopefully that makes sense. Have a go at some of the problems, and that's where we'll leave this one. Cool.